Hello everyone, welcome to solve this nice math Olympiad algebra problem. Here we have p plus q equals to 9 and pq equals to 81, and we solve this problem for the values of p and q. So here first we call this is our equation number 1 and we call this is our equation number 2, and now here we focus on equation number 1 so that from equation number 1 we have here we need to move this p to the right hand side so that we write our q equals to 9 minus p, and we call this is our equation number 3. So now here we use this equation number 3 in equation number 2 so that our equation number 2 is implies that this is pq and the value of q is 9 minus p. We substitute it here and it will be written as p times of 9 minus p equals to 81. So further we need to multiply this p on both of these terms and it will be written as 9p minus p times of p becomes p square equals to 81. So this equation will becomes quadratic in p variable but not in standard form. So now here first we need to convert this into the standard form so that we move these two terms to the right hand side. So you see that this is minus p square. When we move in the right hand side it will becomes plus p square. This is plus 9p. When we move in the right hand side it will becomes minus 9p, and this is 81 equals to 0. So here this is our equation into the standard form. So now we need to apply the quadratic formula in order to solve this quadratic equation. So first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 9, and c equals to 81. So these are the values of a, b and c. And now here we use the quadratic formula. So that quadratic formula is stated as p is equals to minus p plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula, and now here we need to substitute the values of a, b and c in this formula. So it will be written as this is minus b and the value of b is minus 9 plus minus square root of b square. So b is minus 9 square minus 4 times of a is 1 and c is 81, and it is divided by 2 times of a. So here our a is equals to 1. So further you see here we have p is equals to, this is minus times of minus becomes plus 9 and plus minus square root of this minus 9 square equals to 81 minus 4 times of 81 equals to 4 ones are 4 and 4 eights are 32. So it will becomes 324, and it is divided by 2 ones are 2. So 81 minus 324 equals to 9 plus minus. So this subtraction equals to minus 243, and it is divided by 2. So after that we need to focus on this radical term, and we write it as p equals to 9 plus minus. Here we need to break this term and we write it as square root of 243 and square root of minus 1 divided by 2. So after this step we need to focus on this radical term. So we have p is equals to 9 plus minus. We write this 243 as 81 times of 3. We know that 81 times of 3 becomes 243, and we write this minus 1 square root as iota, and here we divide it by 3. So after this step here we just apply this square root on both of these terms separately. So it will be written as p is equals to 9 plus minus. We know that square root of 81 equals to 9 into square root of 3 into iota, and it is divided by 2. So these are the two values of p. So now here from two values of p we need to find the corresponding values of q. So here we need equation number 3. So equation number 3 is implies that q is equals to 9 minus p. So here we substitute these two above values separately here. So we write it as, here we put the positive value 9 plus 9 into square root of 3 iota divided by 2, and here we put the negative value, it is 9 minus 9 into square root of 3 iota, and it is divided by 2. Okay, so after that we need to substitute these two values to the above equation. So here our above equation is written as q is equals to 9 minus p. The value of p is 9 plus 9 into square root of 3 iota divided by 2. So here we again take the LCM of this term. So the LCM of this term is 18, and here we write this, multiply this minus sign on both of these terms. It will be written as minus 9 minus 9 times of square root of 3 into iota. Okay, so here we write it as q is equals to 18 minus 9 becomes 9 minus 9 times of square root of 3 iota, and it is divided by 2. This is the value of q corresponding to the value of p is this one. Okay, so now here we move towards our second case. So we substitute this value of p here and we find the corresponding value of q. So we have q equals to, this is 9 minus p. So we have 9 minus the value of p is this one. So we put this value here. It will be written as 9 minus 9 times of square root of 3 iota divided by 2. So here we need to take again LCM of this term. So we have, this is 2 9s are 18 minus these two are cancelled by each other, and we get here, we need to multiply this minus sign on both of these terms. It will becomes minus 9 plus 9 times of square root of 3 iota. Okay, so here we write it as q equals to 18 minus 9 becomes 9 plus 9 times of square root of 3 iota, and it is divided by 2. So this is the value of q corresponding to the value of p is this. Okay, so finally we have the two roots of the given equation are, so first we write p1 and q1, it is equals to 9 plus 9 into square root of 3 iota divided by 2, and the second q1 is 9 minus 9 into square root of 3 iota divided by 2. Similarly, the second root of the given equation is p2 and q2 is, so our p2 is 9 minus 9 into square root of 3 iota divided by 2, and q2 is 9 plus 9 into square root of 3 iota divided by 2. So these are the two solutions of the given equation, and now here we need to verify these two solutions. So in order to verify these two solutions, here I can just verify the one solution and I can left the second solution for up to you. So here we have the two given equations are p plus q equals to 9 and pq equals to 81. So here we verify our first solution, these two values. So now we put these two values on both of these equations. So it will be written as p plus q. So p is 9 plus 9 into square root of 3 iota divided by 2, and q is 9 minus 9 into square root of 3 iota divided by 2 equals to 9. So here we need to take the LCM of this term. So LCM becomes 2, and we get 9 plus 9 into square root of 3 iota plus 9 minus 9 into square root of 3 iota equals to 9. These two are cancelled by each other, and we get 9 plus 9 is 18 over 2. So here you have 2 9s are 18. So this implies that 9 equals to 9. This shows that the values of p and q satisfies the first equation, and now similarly we check the this value into the second equation. So now we copy down the second equation here, pq equals to 81, and now we put the values of p and q here. So the value of p is 9 plus 9 into square root of 3 iota divided by 2, and the value of q is 9 minus 9 into square root of 3 iota divided by 2 equals to 81. So here in the numerator you gives us this formula 9 square minus 9 into square root of 3 iota square, and in the denominator we have 2 times of 2 is 4 equals to 81. So you see that we have 9 square becomes 81 minus this 9 square is 81 into this square root of 3 square becomes 3 and iota square equals to -1 and divided by 4 equals to 81. So here we need to take common 81 from the upside and we get the remaining terms are 1 and this minus terms of minus become plus and this is 3 and it is divided by 4 equals to 81. So this 4 is cancelled out by this 4 and finally we get here 81 equals to 81. This shows that the values of P and Q satisfy the second equation as well. And this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.